Hello everyone. So in this video, I will solve problem 10 from final exam review practice problems that I sent to you. So in this problem, we are asked to reduce the state table that you have in the question by using the implication chart. So remember that we had two ways to reduce the state table. One was we only check the rows and we would see which ones are can be the same or they are the same. And then the other way was by implication chart. So we have to make sure that we are looking at the output. So if we want two states to be equivalent, their output should be the same. Okay, so if, for example, for one state you had z, the output equal to 0, and for the other one z was 1, we cannot make these two states equal with no conditions, okay? So it should be the same. So let's see here what we have. So we know that in our rows, we will have A, B, C, basically the columns, A, B, C, D, E, F, G, and H. And then in our rows, we're going to have B, C, D, E, G, H, and I. So why don't I have, for example, from A to I and from A to I for both the columns and rows? Because we know that we do not want to have, for example, A cell or I cell. Okay. All right. So let's start from the first row of the table. So I'm going to number the rows of my table so I can refer to them. So row number 1. Let me write it here. Okay, this is not cooperating. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. So let's look at row number 1. So row number 1, we have present state as A, and then we have next states as E, and then the output is 1. So we want to first compare row 1 and row 2. So A and B. Let's look at the outputs. Are the outputs the same? Yes, we see that for both of them, we have outputs equal to 1. Okay, so what we can do is that we only need to look at the next states for x equal to 0 and x equal to 1. So when x is equal to 0, the next state of A is E. And when x is equal to 0, the next state of B is C. So if C and E are equivalent, and also, so for 1, it's E and E, okay? So it's okay. We don't need to write anything because they are the same. So if E and C are equivalent, then we can say that states A and B are equivalent. Now we will compare A to C. So it will be rows 1 and 3 in the table. So the outputs you can see that are not the same. For C, the output is 0. For A, the output is 1. So there is no condition that we can have these two states being equivalent. For A and D, the outputs are the same. So if I want A and D to be the same, to be equivalent, row 1 and 4, we see that E and H should be equivalent, and also E and A. Okay, so E, H, E, A. All right, now let's go to the next one, which is row 5. So now I'm comparing row 1 with row 5, A and E. So do they have the same outputs? No. So A and E, there's no condition that they can be equivalent. Then let's look at row A and F, which are rows 1 and 6. So again, their outputs are different, so they cannot be equivalent. Now we go to row G, which is row 7, and we compare A to G. We have the same outputs. So let's look at their next states. So E and H, E and B. Okay, so E equivalent to B, E equivalent to H. So what I'm writing in this implication, so basically implication chart is what you're seeing here. So in this implication chart, I'm writing the conditions that will make some states being equivalent to each other. So now let's compare row 1 and row 8. So we see that A and H do not have the same output, so there's no condition that they can be the same. Then A and I, which is the first and last row, so they have the same output, so their next states, if they are the same or equivalent, we can say that A and I are equivalent. So there will be E, F, and E, B. All right. So we fill out one column of this implication chart. So now let's go to the next column. So next column is comparing state B to other states. All right. So from here on, we will compare row 2 until 9. So row 2 to 3, 2 to 4, until we reach state I. All right. So row 2 and 3 clearly cannot be compared. They have different outputs, right? Row 2 and 4, they can be compared because they both have output equal to 1. So if C is equivalent to H and E is equivalent to A, we can say that these two states are equivalent. Then if we go to row 2 and row 5, so I'm comparing B and E, you see that they have different outputs. So it is not possible. Then we were at E, now we're at F. So row B, state B and state F, which are row 2 and 6, they have different outputs. So again, it is not possible. Then we go to B and G. They do have the same output. Both of them, the outputs are 1. So the next states are C and H, and E and D. E and B, sorry. C, H, E, and B. All right, now we will compare B with H. They have different outputs, so it will be cross here. And then B and I, they have the same output, so there might be some chance that these two states are equivalent. E and B. All right, now we'll move on to the next one, which is comparing state C with other states. So one by one. C and D cannot be compared. They have different outputs. C and E can be compared. So I and I, which are the same. So H, F is a condition for which C and E can be equivalent. Now C and F, they do have the same output. So their next states are I, E, and H, G. Okay. Then C and G, they have different outputs, so they cannot be the same. C and H, they have same outputs, so I, C, H, D. And C and I, they don't have the same output, so they'll be crossed out. Now we go to state D. D cannot be compared to E and F. Why? Because their outputs are the same, so I'll just cross them out. D and G, they both have output equal to 1, so A equivalent to B is the condition in which D and G will be the same, will be equivalent states. Then D and H, they have different outputs, and then D and I, they have the same output, so their condition would be HF and AB. All right. Now we go to row E, and compare it with other states. So E and F, they have the same output. So the condition in which they might be equivalent is that I equivalent to E and F equivalent to G. Then E cannot be compared to G. E and H, they can be compared. So I and C, F and B, F and D. Sorry, we are in row H. And then E and I cannot be compared. Now we go to row F. So F cannot be compared with G. F can be compared with H. So that would be E, C, G, D. Then F cannot be compared to I. Then we go to row G. So G cannot be compared to H. Clearly, they have different outputs. And then G and I, they have the same outputs. So H, F, and B, which are the same. So B only. We don't need to write this here. All right. And then the last one is comparing H and I, which cannot be the same because they have different outputs. Now, what we'll do here, so this was the first step of our table. Now we'll go to step 2. So in step 2, you have to look back in your implication chart. Wherever you have the cross, you have to look at the conditions that you wrote there. If any of those conditions are the same as the cross that you're finding, then you have to cross that condition out because it can never happen. For example, let's see here. So I am at column A. Okay, first one is AC, which cannot happen, right? A and C, there is a cross in the cell. So let's look back at our conditions that we wrote. Do we have any AC? No, we don't have any AC. All right, so we'll go to the next cross. Next cross is AE. So clearly, this implication chart at the first step, it is telling us that AE cannot happen. Why? Because there's a cross there, and it means that their outputs are different. So we cannot put the equivalency of A and E as a condition for other states to be equivalent, right? So wherever I have AE, I have to cross it out. So one is here, the other one is here. Let's see if we have any AEs left, which we don't have any. All right. Now, next one is AF. Let's see if we have any AF condition, which we don't. And next one is AH, that we don't have any AH as our conditions. So we'll move on to column number 2. So column 2 is B. So as you can see in this step 2 of our implication chart, we are adding more crosses to the table. Okay, so first one is BC. BC is the first cross that I have in my column B. So let's see if I have any BC available. Okay, so it seems that we don't have any. Next one is BE. Do we have any BE available? Yes. So one BE is here. The other one is here. Here and here. Do we have any other BEs left? No. So we'll move on to BH. Do we have any condition as BH? Which we don't have. So we'll move on to column C. So first one is CD. Do we have any CDs available? No, we don't have. Then we're going to have CG. And clearly we don't have any CGs available in our conditions. Okay, so we'll move on to column D. All right, so in column D, first one is DE. Let's see if we have any DE in our conditions, which we don't. What about DF? We don't have any. Oh, we have one DF here, over here. And the next one is DH. Let's see if we have any DH available. DH, yes, we have one here. And that's it. All right. So next one, which is column E. So EG is the first one that cannot happen. So let's see if we have any EG, which we don't. And then let's see EI. Do we have any EI? Yes, we have one EI here and YEI here. Then we will move on to column F. So FG is one of the conditions that cannot happen, that we don't have any. And next one is FI, that we don't have any. So we'll move on to column G. So GH cannot happen. We don't have any condition as GH. And then that's it. And then for HI, which we don't have any. Okay. So now what we have to do is to look back at the new crosses that we did in red and see if there is anything else in the conditions that are inside these crosses. Okay, so let's see if we have any. So the best way here is that since we don't have that much of a conditions left, the ones that are not crossed out, so we can look at one by one of them and then look at the implication chart to see if at that place we have a cross. For example, at column A, the first one is CE, right? Let's see if CE is a forbidden state, which is not, right? So CE is here. So it's not a forbidden state. So this can stay. Next one is HF. Okay, so HF, let's see, H, which is this row, and F. So it is not a forbidden state. Okay, so that can be here as well. Then next one is AB. Clearly AB is not forbidden, so this one is okay. So we don't have to cross it out. Then we go down here, this cell over here. So AB is not a forbidden state. What about HF? HF is not a forbidden state as well. So this can stay here as well. And here we have HF. So there is no other conditions that we have to cross it out, okay? Okay, so here are the conditions that we can have in order to have to reduce the table, right? So let's see what are the conditions. So first one up there, we have C being equivalent to E. Then we're going to have H equivalent to F. What else we have? A equivalent to B. Then we have C and E, we just wrote it. And then we have G equivalent to D equivalent to G. And that's all conditions that we have, right? Yeah. Okay, so what we have to do now is that I have to reduce the table. So our goal for writing this implication table is to reduce my table, right? The original table that I have. So let's substitute the states with what we have as their equivalence, okay? So I'll start from row 1. So in row 1, I have A, and then instead of E, I can write C. Then this is C, this will remain 1. Then in row B, I know that B is equivalent to A, C is C, so it doesn't have any equivalent. It is C, and then E has equivalence of C. So clearly, you see that these two rows, row 1 and 2, are the same right now. So I'm going to cross row 2 out. Then I go to row 3. So we have C, and then we have I and H. What is H? So I can substitute H by S. Okay, I'm not going to touch I for now. You'll see later that we can cross things out with that. Okay, then what else do we have? In state D, I can substitute H by F, and I can substitute A, so nothing by A, it will remain the same. Then what we have is state E, so we know that we want to substitute E by C, and then I will remain like I, and then we have F. So clearly, row 3 and 5 are the same right now, so I'm going to cross this one out, right? Then what else do we have? So I have row F, and then the next state is E, so I'm going to substitute E by C. And then I have G, and I will substitute G by D. Okay, then row G, I said that I'll substitute it by D, and then H is F, and B is A. So clearly, row 4 and 7, they're the same. So I'm going to cross out row 7. Then I go to row 8. So I'm going to substitute H by F. C will remain the same, and D will remain the same. So you can see that row 6 and 8 are the same. So I'm going to cross out row 8. Then row 9. So row 9, I have I, right? And then I have F, which will remain the same. And then I have B that I will substitute it by A, right? So what is happening here? You will see that row 4 and 9. Actually, yeah, row 4 and 9, they have the same next states and they have the same output. So it means that these two states are the same. Which are these two states? It is D and I. So wherever I have I, from now on, I'm going to substitute it by D. And then I have to cross out row 9. Because if I substitute I by D, I have F and A. So now row 4 and 9 are the same. So I'm going to cross it out. And wherever in my table we have I, I'm going to substitute it by D. Okay, so now from 9 rows, my table reduced to only 4 rows. So in your exam, don't forget that you have to write this last reduced table for me if it has some points. Okay, so don't forget to write it out. Next state, and then the present output. Okay, so we have A, C, D, and F. Then here we're going to have C, D, F, C, C, F, A, oh, D, no, A and D. Then the outputs are 1, 0, 1, 0. All right, so we use this implication chart to reduce the table. I hope you understood this problem and how to solve it. If you have any questions, you can leave it in the comments down below. And thanks for watching.